Okay, in this question, we have two boxes that are attached via a pulley, and an acceleration will occur together. It's logical to guess that the 10 kilogram will pull down and the 5 kilogram will be pulled up. So let's identify our direction this way as being positive. That means any force going around this direction will be positive. Any force going this way will be negative. One more time, let's look at the forces on each object. The force on the 10 kilogram object would be force gravity downwards and tension force upwards. The force net equation then would be force net is equal to force gravity minus force tension. And remember, force tension is going in the opposite direction. Always plugging in mass times acceleration, we'll say 10A is equal to 10 times 9.8 minus force of tension. So that's 10A equals 98 minus force of tension. Okay, on the left side here, force gravity pulls down. This will be in the negative direction because it's going opposite the way we said that is positive. And force tension is upwards. This equation would then be force net equals force tension minus force gravity. That would be 5A is equal to force tension minus 5 times 9.8. Or 5A equals force tension minus 49. Now we have two unknowns. We want to find the acceleration of the system, and we want to find the force tension in the cable. So what we need to do is add both equations together by systems of equation method, and we will then be able to solve for the acceleration. So we'll say 5A is equal to force tension minus 49. Adding both equations together, we get 15A is equal to 98 minus 49. We can then quickly solve for the acceleration, and it equals 3.3 meters per second squared. Now to get the force tension, we need to plug that value back into one of the other two equations. Let's choose the first equation. So we'll have 10 times 3.3 equals 98 minus force of tension. Solving for force tension, we get 65 newtons. The second question here, similar idea. We have a pulley system, except this time we have the other box on a horizontal incline. Of coefficient of friction would be 0.10. The equation for this box remains the same as in the previous example. Force gravity downwards, force tension upwards. We then get force net is equal to force gravity minus force tension. We believe the system will accelerate this way, so we'll still keep that direction being positive. So we get 10A is equal to 10 times 9.8 minus force tension, or 10A equals 98 minus force tension. Now the box on the horizontal incline will then have force tension to the right, an opposing force with force friction to the left, and we would need to draw in force gravity and force normal. Since we're on a horizontal surface, force normal and force gravity equal each other. Looking at this one, the net equation must be force tension minus force friction. So we'll do force net equals force tension minus force of friction. Plugging 5A in for force net equals force tension minus the friction force. Now, friction force is always force normal mu. So we'll do 5 times 9.8, because force normal will equal force gravity, and multiply that by 0.10, the coefficient of friction. So again, this is our force normal, which is force gravity, multiplied by the coefficient of friction. We then get 5A equals force tension minus 4.9. Once again, we have two unknowns, but we do have two equations. We can add the equations together. Bring this over. We have 5A equals force tension minus 4.9. We then put both equations together. We will then get 15A equals 98 minus 4.9. Solving for the acceleration, we get 6.2 meters per second squared. One more time, we need to plug this back into one of the above equations. I'll choose the first equation again. We get 10 times 6.2 equals 98 minus force of tension. And this time, force tension is equal to 36 newtons.